Introduction to xlsxwriter. xlsxwriter is a Python library for creating excel.xlsx files. It is used for writing, formatting, and customizing Excel spreadsheets. Real-world uses include generating reports, exporting data, and automating spreadsheet creation. You do not need to have Excel installed to create .xlsx files. It supports advanced Excel features like formulas, charts, and formatting. Running the cell now. To install xlsxwriter on Windows, open a command prompt and run pip install xlsxwriter. Then, import xlsxwriter in your code. We are adding comments for users who need to install xlsxwriter first. Type this in your command prompt to install xlsxwriter. Now we import the xlsxwriter library in Python. Running the cell now. Core concepts in xlsxwriter. The workbook object is the Excel file you create. The worksheet object is a single sheet inside your Excel file. Format objects let you style your cells. You use methods like write and write_o to add data. Running the cell now. We use print to say that we are creating a new Excel file. We make a new workbook object named demo.xlsx. We add a worksheet to our workbook. We print a message to confirm creation. Running the cell now. This output confirms the creation of a new Excel file named demo.xlsx and the addition of a single worksheet inside it. Notice how the print statements communicate each step, aligning with the lesson's goal to introduce the workbook and worksheet objects as core components when starting an Excel file with xlsxwriter. We write the text "Hello World" into cell A1. We print a message explaining what was done. Running the cell now. The output confirms that the string "Hello World" was successfully written to cell A1 of the worksheet. This simple example demonstrates the basic use of the worksheet object write method to add content to a specific cell, reinforcing how data placement works in xlsxwriter. We save and close the Excel file. We print a final message that the file is done. Running the cell now. This output confirms that the workbook object has been successfully saved and closed, finalizing the Excel file. It signals that all prior write operations to the worksheet are complete, reinforcing the importance of closing the workbook to ensure data integrity. Now opening the new demo.xlsx file so you can see the created spreadsheet. Create a new workbook called numbers.xlsx. Add a worksheet to the Excel file. Write the number 123 into cell A1. Write the number 456.78 into cell A2. Write some text into cell A3. Save and close the workbook. Running the cell now. Let us view the numbers.xlsx file to see the numbers and text written in the cells. We create another workbook named row_and_col.xlsx. We add a worksheet. To write by row and column, use numbers that start from 0. Here, row 0, column 0 is A1. This writes the number 100 at row 1, column 2, which is cell C2. We save and close the file. Running the cell now. You can now open row_and_col.xlsx to check writing by row and column indexes. Create a workbook with multiple sheets called multiple_sheets.xlsx. Add a worksheet named data. Add another worksheet named summary. Write some text into cell A1 of the data sheet. Write text into cell A1 of the summary sheet. Save and close the workbook. Running the cell now. Let us open multiple_sheets.xlsx to see sheets with names and data. Here we create a file with formatting named formatted.xlsx. Add a worksheet to the workbook. Create a format object for bold text. Write bold text into cell A1 using the format object. Write normal text into cell A2. Save and close the workbook. Running the cell now. Let us preview formatted .xlsx with bold and normal text in different cells. Create a new file called column_width.xlsx. Add a worksheet. Set column A width to 30 so text fits better. Write a note to cell A1 explaining the width. Close and save the file. Running the cell now. Now let us open column_width.xlsx to see the column with a custom width. Create write_o_col.xlsx. Add a worksheet. Write several numbers across row 1 starting at A1. Write several letters down column B starting at B2. Save and close the file. Running the cell now. Open write_o_col.xlsx to check writing multiple items in a row and a column. Now let us look at formulas inside Excel with xlsxwriter by creating formula.xlsx. Add a worksheet. Write the number 10 in A1. Write the number 20 in A2. Put a formula in A3 that will add cells A1 and A2. Save and close. Running the cell now. Time to open formula.xlsx and see a cell with a formula that calculates values. We will now see how to use conditional formatting in an Excel file. Add a worksheet. Use a loop to write numbers 1 to 10 in column A. Each number goes into a different row. Apply a 3-color scale conditional format across the range A2 to A11. Save and close the workbook. Running the cell now. Now let us check conditional.xlsx showing color scales for data values. Here we create an Excel file with a chart called chart.xlsx. Add a worksheet for our data. Write some numbers into rows in column A. Each value is written into its own row. Create a column-type chart. Tell the chart to use the data from our range. Insert the chart into worksheet at cell C1. Save and close the file. Running the cell now. Now open chart.xlsx and look for the column chart created from your data. This time we will insert an image into an Excel file called image.xlsx. Add a worksheet. Write a label above where the image will go. Insert an image. Save and close the workbook. Running the cell now. Let us open image.xlsx and see the inserted image in the spreadsheet. Now let us check for missing libraries. Try to import xlsxwriter. If successful, tell the user it is installed. If there is an importer, warn the user that xlsxwriter is not installed and show how to install it. Running the cell now. This output confirms that the xlsxwriter library is successfully installed, which is essential for creating and formatting Excel files in this lesson. Without this library, none of the workbook, worksheet, or formatting methods demonstrated later can be used. Ensuring xlsxwriter is available is the first step before moving on to writing and styling Excel sheets. Now we purposely try to write to an invalid file path. Create a workbook at a location that likely does not exist. Try to add a worksheet and write some data. Try to close the file. This may cause an error. If something goes wrong, catch the exception. Print out the error message we caught. Running the cell now. This output shows an error caught when trying to create a workbook in an invalid file path. It highlights the importance of providing a valid file location when initializing the workbook object, as the program cannot write to a non-existent directory. This reinforces the lesson's focus on the workbook as the Excel file handler and the need to manage file paths correctly. Now let us demonstrate an error when trying to write to a read-only file. Create a normal workbook. Add a worksheet to it. Write some data. Save and close the file. Import OS library to change file permissions. Make the file read-only now. Try to write to it again. Attempt to close it. Catch the error and print it. Finally, set the file permissions back to normal so we can edit it again. Running the cell now. The output shows a permission error when trying to write to a read-only Excel file, illustrating how the workbook object cannot overwrite files without proper access rights. This highlights the importance of handling file permissions and exceptions when working with xlsxwriter's write method to prevent crashes in your code. Best practices and common patterns with xlsxwriter. Close all workbooks using workbook.close to save your files. Use with open fname.xlsx as F to read output files. Reuse format objects to save memory and speed up your code. Always handle exceptions for file paths and permissions. Create functions to handle repeated tasks. Running the cell now. Let us create a function to make a simple report. Open a workbook using the file name given. Add a worksheet. Write header labels name and score at the top. For every name and score in the data, add a new row. Write the name and score into that row. Close the workbook to save it. Print a message showing the saved file name. Running the cell now. We create a list of names and scores. Call our function to make a simple Excel report. Running the cell now. The message report saved to scores.xlsx confirms that the workbook was successfully closed and saved, demonstrating the crucial best practice of calling workbook.close to ensure data is written to the file. This output highlights the importance of properly managing file saving when using xlsxwriter, aligning with the lesson's focus on reliable file handling. Let us open the generated scores.xlsx to see the name and score report. Now let us build a multiplication table using xlsxwriter. Define a function that takes a size and file name. Create the workbook. Add a worksheet. Write the numbers 1 to n across the top row. For each row, add the number for the row and then the multiplication results. Write the value for each product in the correct cell. Close and save the workbook. Print out a message showing where the file is saved. Call the function to make a 10 by 10 multiplication table in Excel. Running the cell now. This output confirms that the multiplication table for numbers 1 through 10 has been successfully written to the specified Excel file and saved. Notice how the code includes both row and column headers, creating a clear, structured table. This reinforces the best practice of closing the workbook with workbook.close to ensure the file is properly saved and accessible. Now open multiplication_table.xlsx to see the completed multiplication table as a spreadsheet. Thank you for watching. Like and subscribe for more Python tutorials. Comment below on what you want to learn next. Running the cell now.